Hello everyone, my name is JP and I'm the Director of Engineering at Tractian. Today I'm going to talk about our experience with real-time machine learning using Scylla. This is our agenda for today. I will start talking about what Tractian is and what we do, what our infrastructure looks like, why we migrated away from Mongo for some workloads, our migration process, and what is next for us. At Tractian, we build solutions for industrial maintenance, and we want to empower maintenance teams around the globe with the best-in-class hardware and AI-assisted software. At Tractian, we build solutions for the industrial maintenance. We want to empower the maintenance teams around the globe with the best-in-class hardware and AI-assisted software. We have 3 products. The Smart Track is a vibration and temperature sensor that is able to detect more than 70 types of failures in rotating machines. The TrackOS is a system with everything needed to manage the operations of maintenance teams on the plant floor, enabling mobile and offline operations. And the Energy Track is a sensor that is able to monitor energy consumptions, efficiency, and electrical failures. These products together form a very concise solution that works seamlessly with one another, bringing a very Apple-like experience for the industry maintenance. We already have raised over $100 million through VC funding, establishing a global footprint with customers in all the American continent. We have 3 different headquarters, one in Brazil, one in Mexico, one in the USA, and employees worldwide. Let's talk about our tech stack. We have a very straightforward approach to adopting new technologies. If it helps solve a real problem, we embrace it. For this reason, our tech stack is very modern and extensive. We use more than 80 databases and 6 different languages for our services. This allows us to leverage the strengths of each technology. We have a microservices architecture with more than 30 services, ranging from APIs, consumers, producers, and batch processes. They all handle more than 1,500 events per second from different sources, doing so with an average latency lower than 200 milliseconds and a 99.95 availability. This is how our infrastructure looked like before Scylla. The sensor sent data to our APIs, and the APIs put the sensor data into Kafka topics. We had different services that would consume these topics to process the data, saving it to Mongo into different collections. And after that, we send triggers to the AI pipeline to process the data. In detail, we start with a binary blob from the sensor, and the processing services expand the data to different tables. Some use it for client visualizations, others as vectors for the AI used during training and inference. As the company grew, the number of samples arriving to the system also grew. We saw a more than 2x increase on our workloads in a single year, and the database needed to deal with that increase. Unfortunately, even after upscale operations and optimizations, that was not the case. Degradation in performance made us look for alternative solutions for our warehouse and AI workloads. Why Scylla? At the time, we already tested Cassandra, and the results were promising. But some database operations like upscaling had some aspects that were not attractive to us. Mongo was not handling the IoT workload very well, and we wanted something that was easier to scale. Scylla showed itself to be a light at the end of the tunnel. We were searching for something really specific, and to our luck, Scylla had a data model that fit our problem very well. Also, the database operations were way better than Cassandra's. This is just one example on how Scylla data model works in favor of our workloads. In this case, we have some binary data that we want to store, partitioning by sensor ID and ordering by the timestamp. Scylla will make this query for a specific ID and a time window very fast in this case. We had a plan on our hands. First, create a new DSL. What do the tables on Scylla would look like? How would Mongo data map to the new tables? After that, we did a bunch of theoretical benchmarks, which is basically testing with synthetical data. This is an easy and fast way to validate an idea. Then, we did it all over again, but now with real data. Sometimes syntactical tests fail to map some nuances of real data and miss things like partitions hotspots. Other times, they fail to create a good mapping, and this only becomes visible when you test with real data. So it's important to not skip this step. After this, it's time to get into the weeds and refactor all the existing application code to use the new database. It's important to have a very clear success criteria. What are you trying to achieve with this migration? We had a very clear number of devices in mind that the new infrastructure should be able to handle. The test results came in favor of Scylla. In some workloads, we saw an increase of 10x in throughput and latency. Now, I want to talk about the migration game plan. We did everything live and without downtime. This was the initial setup. All the data was being written to Mongo. After that, we started to write to both databases. This is the first checkpoint of the migration. At this step, we checked to see if both databases agreed, if the data was correct, and if the initial performance tests agreed with the benchmark ones. After that, we started our migration script, which would backfill Scylla with the historical data from Mongo, also doing checks along the way to see if no data was missing. Then, we switched the reads to occur now on Scylla, continuing to write on Mongo as a backup if any problem occur. And this is how we did our online, no downtime migration. The results speak for themselves. We have a great write and read latency after migration, and Scylla has scaled very well with our increasing workload. Our infrastructure now has Scylla as one of its backbones, and we still use Mongo for other types of workloads, and also a bunch of other databases for other challenges. But not everything is perfect. During the migration process, we hit some walls. A memorable bug was one that we found on a Python driver that caused a huge speed bottleneck to our queries. The Python driver did deep copies of objects, and our nested structure was creating an awful slowdown. We had to search for a fix, and in this case, we jited the RRM and we did the conversion ourselves. To conclude, do not fear tech. It can be frightening at first, but it usually shows a better way of doing something that you were doing before. We have a very clear commitment to keep raising the bar in tech, people, and products. If this is the kind of work environment that you seek, check out our careers page. Also, feel free to check out any of my social links and reach out if you want. Thanks for watching.